In yesterday's class, we have discussed about vibrational rotation spectra, right? Now let us discuss Raman spectra. Okay, now is the Raman spectra. It is Raman spectra. Okay, Raman spectra. Raman spectra ನೋಡ್ರಿ ಏನು ಹೇಳ್ತದ? When a beam of visible or UV radiation is incident on gas, when a beam of visible or UV radiation is incident on gas or liquid or transparent solid. So when a beam of visible or UV radiation, beam of visible or UV radiation is incident on gas, liquid, or transparent solid. A fraction of radiation is scattered. ನೋಡಿ ಇನ್ಸಿಡೆಂಟ್ ಲೈಟ್ ಏನು ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರ್ತದ UV ರೇಡಿಯೇಷನ್ ಆರ್ ವಿಸಿಬಲ್ ಲೈಟ್ ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ ಸ್ಕ್ಯಾಟರ್ಡ್ ಆಗುತ್ತೆ. ಸೊ ಫ್ರಾಕ್ಷನ್ ಆಫ್ ರೇಡಿಯೇಷನ್ is scattered. Fraction of radiation is scattered. Radiation is scattered. Fraction of radiation is scattered in all directions. In all directions. In all directions. Scattered radiation consists of scattered radiation consists of lines of same frequency or consists of lines of same frequency or changed frequency. Okay, means molecule in the end light incident ಆಗಿರ್ತದೆ ಅದು scattered ಆದ ನಂತರ ಬರೋದು radiation ಏನದ. So after scattering, for example, let us consider this is a molecule. Correct ಇಲ್ಲ molecule ಅದ ಅಂತ ಅನ್ಕೋರಿತಾರೆ. So if light incident on it, ಇದ್ರ ಮೇಲೆ light incident ಆಯ್ತು ಅಂತಂದ್ರೆ ಆಟೋಮೆಟಿಕ್ಲಿ ಏನಾಗ್ತದೆ ಇದು ಸ್ಕ್ಯಾಟರ್ಡ್ ಆಗ್ತದೆ ಲೈಟ್ ಆ ಕಡೆ ಈ ಕಡೆ ಬೇರೆ ಬೇರೆ ಡೈರೆಕ್ಷನ್ ಸ್ಕ್ಯಾಟರ್ ಆಗ್ತದೆ. ಇನ್ಸಿಡೆಂಟ್ ಲೈಟ್ ಏನು ಫ್ರೀಕ್ವೆನ್ಸಿ ಅದ ಅದೇ ತರ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರುವಂತದ್ದು ಲೈಟ್ ಏನು ಸ್ಕ್ಯಾಟರ್ಡ್ ಆಗ್ತದಲ್ಲ then that is ಸೇಮ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಗಿರಬಹುದು ಆರ್ ಇಟ್ ಮೇ ಬಿ ಡಿಫರೆಂಟ್ ಪ್ಲಸ್ ಆರ್ ಇದು ಮೈನಸ್ ಅಂದ್ರೆ ಕಡಿಮೆ ಇರೋದು ಅಥವಾ ಹೆಚ್ಚು ಇರೋದಾಗಿರ್ಬೋದು. Changed means it may be, see, let us consider incident is f naught attu ಅಂದ್ರೆ that scattered radiation ಏನದಲ್ಲ that scattered radiation may consist of lines of same frequency or changed frequency. It may be needs incident light is going to be maybe f naught ಇರಬಹುದು or it may be f naught some plus delta f ಇರಬಹುದು or it may be if it take this one as a minus it is plus the one, or it may be changed means f naught minus delta f ಇರಬಹುದು. ಹೆಚ್ಚು ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರಬಹುದು ಕಡಿಮೆನೂ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರಬಹುದು or it may be same frequency ಇರಬಹುದು. That is what he has observed. Let us consider nu naught. Here f naught within and nu naught. Nu naught is the frequency of incident light. Frequency of incident light. Okay. Frequency of incident light. Firstly, here we are going to use that electromagnetic wave. Incident light is nothing but electromagnetic wave. EM, that is EM wave, right? So EM wave ಒಳಗಡೆ ಯಾವುದು ಯೂಸ್ ಮಾಡುತ್ತಿದ್ದೇವೆ ಇಲ್ಲಿ? That is UV radiation or ultraviolet. So UV radiation or ultraviolet. One second. Shift in the same ನೋಡ್ರಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ಒಳಗಡೆ ಶಿಫ್ಟ್ ಆಗ್ತೈತೆ ಚೇಂಜ್ ಆಗ್ಯದ ಮೀನ್ಸ್ ಅದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ ಇನ್ನೊಂದು ವರ್ಡ್ ಶಿಫ್ಟ್ ಆಗ್ಯದ ಅಂತ ಹೇಳ್ತೀವಿ. One second. So let us consider this nu naught is the incident radiation. Okay. Here electromagnetic waves are EM waves are UV radiation or UV or visible. UV or visible. UV active molecules ಅಂತಂದ್ರೆ ಯಾವಾಗಲೂ ರಾಮನ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಅನ್ನು ತೋರಿಸ್ತಾವೆ. ಏನಾಗ್ತೈತಿ ಇನ್ಸಿಡೆಂಟ್ ಲೈಟ್ ಏನು ಇನ್ಸಿಡೆಂಟ್ ಆಗ್ತೈತಿ ಅದ್ರ ಮೇಲೆ ಇನ್ಸಿಡೆಂಟ್ ಆದ ತಕ್ಷಣ it is going to scatter the light in having the same frequency, or it may scatter the radiation having the frequency less than the incident one, or it may be greater than the incident one. Therefore ನಾವೇನ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ ಅದ್ರ ಡಿಫರೆನ್ಸ್ here
So, screen is not visible.
sorry. Yes. Is it visible? Disconnect ಆಯ್ತಲ್ಲ. Is it now visible? No. Other variation ಹೆಂಗ್ ತೋರಿಸ್ತಾನೆ ನೋಡ್ರಿ. So let us consider this nu naught is the frequency of incident light. Nu naught is the frequency of incident light. So after scatter ಆದ ನಂತರ it may be having the same frequency, or no, scattered light, scattered radiation is going to have maybe same frequency, or it may be frequency greater than the incident frequency, or the frequency may be less than incident frequency. So what we do here, frequency which is greater than that one, I'm going to write on this side here. So this is going to be nu plus delta nu naught plus delta nu. Then here this is nu minus delta nu. Here see, this is the frequency of scattered radiation, this is the frequency of scattered radiation, this is also the frequency of the scattered radiation. Means it may have same frequency and incident light too. So this is called as same frequency line. This frequency having more value, that is nothing but higher. Not frequency ಜಾಸ್ತಿ ಇದ್ದಂಗೆ wave number ಕೂಡ ಜಾಸ್ತಿ ಇರ್ತದೆ. Nu bar is directly proportional to nu, because nu is equal to c by lambda ಬರಿತೀವಿ. ನಾವು nu can be written as c nu bar ಅಂತ ಬರಿಬಹುದು. Therefore nu ಮತ್ತು nu bar same ಅದಾವ. Therefore this is nothing but higher wave number. And in this case one is lower wave number. Okay. Next, and this line having the same frequency, we call this line having the same frequency after scattering, same frequency incident light at the same frequency ಇತ್ತಂದ್ರೆ ಇದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ ರಿಲೇ ಲೈನ್ ಅಂತ ಕರಿತೀವಿ. We call that one as ರಿಲೇ ಲೈನ್ ಅಂತ ಕರಿತೀವಿ. ಅದಕ್ಕೆ ಇನ್ನೊಂದು ಹೆಸರು ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ we call that one as excited line ಅಂತ ಕರಿತೀವಿ. ನಾನು ಹೇಳ್ತೀನಿ. Moreover, the frequency lines having higher wave numbers are called as anti-Stokes Raman lines. Anti-Stokes Raman lines. In this case, these are called as Stokes Raman lines. Clear? Lower wave number and higher wave number. Let us just observe these values. Okay, is the scattered radiation having the same frequency or higher than that one or lower than that one? And remember, shift on the both the side. Lower ku mattu higher ku adu kade shift ಎಷ್ಟು the value ಇರೋದು? This is delta nu naught only. Shift will be always delta nu naught. This same frequency lines are called as excited lines or relay lines. Excited lines or relay lines. And this ಇದೇನು ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ ನಾವು ಇನ್ಸಿಡೆಂಟ್ ದಟ್ ಇಸ್ ನ್ಯೂ ನಾಟ್ ಆಗಿರ್ತದೆ. ಇಫ್ ದಟ್ ಇಸ್ ನ್ಯೂ ನಾಟ್ ಪ್ಲಸ್ ಡೆಲ್ಟಾ ನ್ಯೂ ನಾಟ್ ಇತ್ತಂದ್ರೆ ನ್ಯೂ ನಾಟ್ ಪ್ಲಸ್ ಡೆಲ್ಟಾ ನ್ಯೂ ನಾಟ್ ಇತ್ತಂದ್ರೆ we call this one as is anti-Stokes Raman, anti-Stokes lines, anti-Stokes line ಅಂತ ಕರಿತೀವಿ. Then in case of nu naught minus delta nu naught, we call this one as Stokes lines. Stokes line. Then this is what our Raman spectra can be visualized. And you see, in case of this Raman's effect only, that is called as Raman effect. When a light incident on a molecule, it is going to scatter the light having the same frequency or maybe less or maybe higher. This phenomena is called as Raman effect. But types of Raman spectra or Raman effects. Raman effect or yet effect better. One is vibrational Raman effect. So types of Raman effect. Types of Raman effect. Raman effect. So first one is that vibrational Raman effect. Vibrational Raman effect. Raman effect. So vibrational Raman effect means the incident photon rotates, vibrates the molecule. ನೋಡ್ರಿ ಆಮೇಲೆ ಇನ್ಸಿಡೆಂಟ್ ಫೋಟಾನು ಆ ಮಾಲಿಕ್ಯೂಲ್ ಅನ್ನು ವೈಬ್ರೇಟ್ ಮಾಡ್ತಿತ್ತು. ಇನ್ಸಿಡೆಂಟ್ ಫೋಟಾನ್ vibrates the molecule. Vibrates the molecule. We call that as vibrational Raman effect. If it rotates, then we call that as rotational Raman effect. Rotational Raman effect. Raman effect. So rotational Raman effect is defined as here. If it incident, it rotates the molecule. Same incident, right? Incident photon rotates molecule. Molecule rotate ಆಯ್ತು ಅದಕ್ಕೆ rotational Raman effect ಅಂತೀವಿ. Vibrate ಆಯ್ತು vibrational Raman effect ಅಂತ ಕರಿತೀವಿ. So Raman shift lies in the infrared region of electromagnetic spectra. It is known as feature of the characteristic feature of the molecule. I mean, moreover, noted this is delta nu is called as Raman shift. Delta nu is called as shift. Raman shift. Note nine are there. Incident light ಯಾವ್ದದ? Here incident light is UV. Incident light to UV or visible ಅದ. Correct? Visible ಅದ. But shift ಆಗ್ತೈತಿ ನೋಡ್ರಿ. ನಾಟ್ ಇರಬಹುದು ಅಥವಾ ಡೆಲ್ಟಾ ನ್ಯೂ ಹೆಚ್ಚಿಗೆ ಇರಬಹುದು ಅಥವಾ ಡೆಲ್ಟಾ ನ್ಯೂ ಕಡಿಮೆ ಇರಬಹುದು. ಈ ಡೆಲ್ಟಾ ನ್ಯೂ ಏನು ಫ್ರೀಕ್ವೆನ್ಸಿ ರೇಂಜ್ ಐತ್ಲ ಹೆಚ್ಚು ಕಡಿಮೆ ಆಗೋದು ಏನು ಡೆಲ್ಟಾ ನ್ಯೂ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಏನದಲ್ಲ ಶಿಫ್ಟ್ ಕಾಲ್ತೀವಿ. ದಟ್ ಇಸ್ ರಾಮನ್ ಶಿಫ್ಟ್. ದಿಸ್ ಲೈಸ್ ದ ಇನ್ಫ್ರಾರೆಡ್ ರೀಜನ್. ಡೆಲ್ಟಾ ನ್ಯೂ lies in infrared region. Lies in infrared region. So Raman effect is the characteristic feature of the molecule, and molecule ಒಂದು ಸ್ಪೆಷಲ್ ಫೀಚರ್ ಇದು. ಓಕೆ, ಸೊ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ಚೇಂಜ್ ಬಂದದ ಅಂದ್ರೆ ಆಟೋಮೆಟಿಕ್ಲಿ ಎನರ್ಜಿ ಕೂಡ ಚೇಂಜ್ ಆಗತ್ತದ್ರಿ. ಎನರ್ಜಿ ಕೂಡ ಚೇಂಜ್ ಆಗ್ತೈತಿ. ಸೊ ನಾವೇ ಡಿಫೈನ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ see, this energy depends on the frequency as like this. E is equal to c h nu ಅಂತ ಬರಿತೀವಿ. So I can rewrite this one as h c nu ಅಂತ nu bar ಅಂತ ಬರಿಬಹುದು because nu is equal to c divided by lambda. Therefore I can rewrite this one as c nu bar. Therefore h c nu bar, or this is also equal to c divided by lambda. So ನಿಮಗೆ ಒಂದ್ಸತಿ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಆಟೋಮೆಟಿಕ್ಲಿ ಏನು ಸಿಗ್ತೈತಿ, ನೀವು ಡೆಲ್ಟಾ ನ್ಯೂ ಸಿಗುತ್ತೆ. ಡೆಲ್ಟಾ ಎನರ್ಜಿ ಈಸ್ ಈಕ್ವಲ್ ಟು h into ಡೆಲ್ಟಾ ನ್ಯೂ ಅಂತ ಸಿಗ್ತದೆ. Then again Stokes ಮತ್ತು anti Stokes lines ಅದಾವಲ್ರಿ, they are going to have the particular intensity. There is one point is there is it's important one. Intensity of Stokes lines is greater than intensity of anti Stokes lines. Remember, intensity of Stokes lines is greater than greater than intensity of anti-Stokes line. Intensity of anti-Stokes lines. Anti-Stokes. Okay. So this is very important. Intensity of the anti-Stokes is greater than intensity anti-Stokes. Means I Stokes are greater than I anti-Stokes. Remember, intensity I means. So relation ratio of I anti-Stokes to Stokes. Ratio of ratio is I of anti-Stokes divided by I of Stokes. Anti-Stokes to Stokes is given by that always equal to e power of minus delta E divided by kBT. Delta E divided by kBT. That's why I wrote here delta E is equal to another h nu delta nu iti. So if I replace that, what I get here I anti-Stokes to I Stokes. So I anti-Stokes to I Stokes. I Stokes is equal to, you can rewrite it as e power of minus h delta nu divided by h delta nu divided by kBT. So this is what exactly the expression for collecting the intensities. Correct? Here we know that I s are greater than I anti-Stokes. Here delta nu is the Raman shift. Raman shift at ಗೊತ್ತಿತ್ತಲ್ಲ automatically ಅದರದ intensity ratio ಅನ್ನು ನೀವು ಕೇಳಬಹುದು. Moreover, Raman effect is also observed due to the change in the polarizability of the molecule. Especially this Raman effect is observed due to Raman effect. Raman effect is observed due to is observed due to change in the polarizability. Change in polarizability. Polarization ಅಂದ್ರೆ ಆಲ್ರೆಡಿ ಗೊತ್ತದ ನಿಮಗೆ. ಸೊ ಅದ್ರ ಮೇಲೆ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್ ಯಾವ್ದಾರ ಇನ್ಸಿಡೆಂಟ್ ಆಯ್ತು ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ದಿಂದ ಅದೇನಾಗ್ತೈತಿ ಮಾಲಿಕ್ಯೂಲ್ ಪೊಲರೈಸೇಷನ್ ಚೇಂಜ್ ಆಗ್ತೈತಿ, ಬಟ್ ಓರಿಯೆಂಟೇಷನ್ ಚೇಂಜ್ ಆಗ್ತೈತಿ. ಅದಕ್ಕೆ ನಾವಿಲ್ಲಿ ಕರಿತೀವಿ ಎಸ್ಪೆಷಲಿ ಲಿಸ್ಟ್ ಆಫ್ ದ ಮಾಲಿಕ್ಯೂಲ್ಸ್. ಈಗ ನಿಮಗೊಂದು ಮಾಲಿಕ್ಯೂಲ್ ಹೇಳ್ಕೊಡ್ತೀನಿ, ಅದರೊಳಗಡೆ ಯಾವ್ಯಾವ ರೋಟೇಷನಲ್, ವೈಬ್ರೇಷನಲ್ ಮತ್ತು ರಾಮನ್ ಎಫೆಕ್ಟ್ ಅನ್ನು ತೋರಿಸ್ತಾವ ಅಂತ ನೋಡೋಣ. ಓಕೆ, so there is one table. So ಇಲ್ಲಿ molecule ಅಂತ ಬರೀತೇನ್ರಿ. Here I'll write this one as a molecule. And here pure rotational. If it shows pure rotational, I'll write here pure rotational. And here vibrational, and it is Raman. Raman. For example, molecules. If I take the molecules like Cl or NaCl or H2O or N2O, then SO2, then NO2, then what has written CO2, not CO2, that is CS3Cl, CS3Cl. ನೋಡಿ ಎಲ್ಲಕ್ಕೂ ಪರ್ಮನೆಂಟ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಭಾಳ ಐತಿ. ಪರ್ಮನೆಂಟ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಇರೋದ್ರಿಂದ ಪ್ಯೂರ್ ವೈಬ್ರೇಷನಲ್ ಯಾವ ರೇಂಜ್ ದಾಗ ತೋರಿಸ್ತೈತಿ ಹೇಳ್ರಿ? ಪ್ಯೂರ್ ವೈಬ್ರೇಷನ್ is always defined in case of microwave region. Microwave region. What about vibrational? It will be always in infrared. What about Raman? It is under UV radiation. UV radiation. So all these molecules will show this Raman, pure rotational and vibrational as well as Raman. It is in case of the molecules like CO2 and CS2. CO2 and CS2. Carbon sulfide and carbon disulfide and carbon dioxide. Okay, so this is first set, this is second set. These are going to possess, it's inactive here. Inactive and meaning it will not show. Here it is active, then this is active. Next set is third set. Molecules are N2, O2 and O2, H2, N2 and O2. These are non-polar molecules. Homonucleus ಅಂತ ಕರಿತೀವಿ. Non-polar molecules. These will not show any rotational, any vibrational, but these will show pure rotational Raman active. Rotational Raman. Rotational Raman effect. Raman effect. Because our incident ಆಯ್ತು ಅಂದ್ರೆ ಈ molecules ಏನಾಗುತ್ತೆ rotate ಆಗ್ತವೆ. Next set is fourth set CH4, then it's carbon chloride, then next CCl4, the next is sulfur fluoride. So all molecules they are inactive here, inactive. These are vibrational Raman effect, Raman active. So rotational Raman aatu ivala vibrational Raman. Vibrational Raman effect ana ತೋರಿಸ್ತಾರೆ. So just to go through this table, then you can have this. Okay. Pure rotational ತೋರಿಸು, vibrational ತೋರಿಸು, then Raman effect ana ತೋರಿಸು. ಈ Raman effect ಒಳಗಡೆ ಇಲ್ಲಿ purely Raman ತೋರಿಸ್ತಾವೆ. But especially ಈ ಎರಡು ಕೇಸ್ಗಳು special cases of Raman effect. Permanent dipole moment ಇರ್ತದ ಅವೆಲ್ಲನು ಮೈಕ್ರೋ ಆಕ್ಟಿವ್, ಇನ್ಫ್ರಾರೆಡ್ ಆಕ್ಟಿವ್ ಅಂಡ್ Raman active ಮೂರು ಇರುತ್ತವೆ. Okay. Then I have the Raman effect is classified into two types. One is vibrational Raman effect. Another ಏನು vibrational Raman effect ಏನು ನೋಡ್ತೀವಿ. See that. The first one is vibrational Raman effect. In this case, first one, vibrational Raman effect. Vibrational Raman effect. Vibrational Raman effect. ನಿಮಗೆ ಆಲ್ರೆಡಿ vibrational ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಗೊತ್ತೈತ್ರಿ. vibration ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಹೆಂಗ್ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ? That is defined as nu. Okay, nu is the represent ಮಾಡ್ತೀವಿ. ನಿಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತದ. Vibrational Raman effect arises due to the transition of a molecule from one vibration state to another vibration state. That is called as under Raman effect. Especially that is nothing but UV radiation. UV radiation fall ಆದ ತಕ್ಷಣ one state to another state vibrationally ಅದು ಜಂಪ್ ಆಗ್ತಿತ್ತು ಅಂದ್ರೆ ನಾವು ಅದಕ್ಕೆ vibrational Raman effect ಅಂತ ಹೇಳ್ತೀವಿ. The selection rule for Raman effect. Selection rules. ನಿಮಗೆ ಆಲ್ರೆಡಿ vibrational effect ಗೊತ್ತದ. Especially Raman ಅಂತಂದ್ರೆ in terms of in case of UV radiation. Molecules automatically vibrate ಆಗ್ತಾವೆ because the transition will take from one vibration state to another vibration in same electronic state. So transition will be from nu 1 to nu 2 in same electronic state. And that's why it is defined as vibrational Raman effect. And the selection rules are here: delta nu is always equal to plus or minus 1. Nodri, pure vibrational ಒಳಗಡೆ vibration delta nu varies from 1 2 3 4 ಹಿಂಗ ಹೋಗ್ತೈತಿ. నేను ಡಿಸ್ಕಸ್ ಮಾಡತ್ತಿದ್ದೀನಿ ನೋಡ್ರಿ. think here see pure vibrational ಆಗಿ ನೋಡಿದ್ರೆ delta nu is 1 minus plus or minus 1 plus or minus 2 plus or minus 3 ಇದೆ. But in case of Raman vibrational Raman effect, its selection rules are only plus or minus 1. And these are harmonic motion, especially this is defined in case of harmonic motion. Harmonic ಒಳಗಡೆ ಯಾವತ್ತು delta nu equal plus or minus 1 ಇರುತ್ತೆ. And harmonic ಬಂತು ಅಂತಂದ್ರೆ varies. And moreover I told this delta nu naught, if the incident radiation or scattered radiation is equal to nu naught ittandre, we call this one as excited line. So this is defined as excited line or relay line. Excited line or relay line ಅಂತ ಕರೀತೀವಿ. Ilan transition ತಗೋತೀವಿ ನೋಡ್ರಿ. If it moves from one state to another state, for example, let us consider the first state is, I will take that one as initial state. Let us take nu. If it takes transition from nu to nu plus 1, nu to nu plus 1. How do you define the wave number for the nu, the quantum number nu? For this, wave number is given by nu bar nu is equal to nu plus 1 by 2 times of omega e. We know already. What about for this case? What about for this case? For this case, nu bar of nu plus 1 state is equal to nu plus 3 by 2 times of omega e. Omega e. Right? If you take the difference between these two, what I get here? So difference between these two. What I get? If I take the difference between these two, generally I go to delta omega. No, delta nu bar anta. Delta nu bar is equal to you add the difference to the only n sigdati plus or minus omega e sigdati. Plus or minus omega e ಅಷ್ಟೇ sigdati. Correct? So this is the in case of Raman. This is in case of Raman. If you see, if you go from that's nu one state to nu naught ಹೋಗ್ರಿ ಏನು ಬರ್ತದೆ? This is also going to be nu e. This nu bar of naught. This line is called as excited line wave number. We call this one as excited line wave number. See what I get here? I define this one as wave number to this wave number. Sorry. Wave number of the vibrational quantum number of nu 1 to nu naught. And what can I write here? Nu bar of 1 minus nu bar of naught is equal to omega plus or minus omega e bರ್ತದೆ. That is the difference. So I can rewrite this one as nu bar of the first state is going to be nu naught plus omega e plus or minus omega ಅಂತೀವಿ. ಈ ತರ ನೋಡ್ರಿ, this is a scattered radiation. This is scattered radiation wave number. Scattered radiation wave number. Meaning, you know, it is going to have plus or minus. It could be. So it's a maybe changed one. So ಇದು ಹೆಚ್ಚಾಗ್ತದ ಕಡಿಮೆ ಆಗ್ತದ. ಹೆಚ್ಚಾಯ್ತು ಅಂದ್ರೆ ಆಂಟಿ ಸ್ಟೋಕು, ಕಡಿಮೆ ಆಯ್ತು ಅಂದ್ರೆ ಸ್ಟೋಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಅಂದ್ರೆ ಈ ನ್ಯೂ ನಾಟ್ ಏನಂತ ನಾವು ನ್ಯೂ ನಾಟ್ ಬಾರ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ excited line wave number. Excited line wave number. Excited line wave number ಅಂತ ಕರಿತೀವಿ. Therefore, one state to another state ಏನಾದ್ರೂ ಕೂಡ ನ್ಯೂ ನಾಟ್ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ ಒಮೆಗಾ ಇ ಇರ್ತದೆ. ಏನೋ ಚೇಂಜ್ ಬಂದ್ರು ಡೆಲ್ಟಾ ನ್ಯೂ ಒಮೆಗಾ ನ್ಯೂ ಇದಕ್ಕೆ ಏನು ಅನ್ಬೋದು? ಈಗ ಯು ಕ್ಯಾನ್ ಕಾಲ್ ದಿಸ್ ಆಸ್ ಡೆಲ್ಟಾ ನ್ಯೂ ಬಾರ್ ಅಂತ ಅನ್ಬೋದು. These are the new bars. These are wave numbers. Okay. This shift will be observed only when the molecule will be harmonic. Remember, this shift will be only, and this one is called as especially Raman vibrational Raman shift ಅಂತ ಕರಿತೀವಿ. This is called as vibrational Raman shift. Vibrational Raman shift. Vibrational Raman shift, or it is also called as fundamental band. Fundamental band. Moreover, this is observed only in harmonic vibration. Observed only in harmonic vibration. You already got to the anharmonic vibration that we have discussed. What about the selection rules for anharmonic vibration? So let me define, that is vibrational Raman effect in case of vibrational Raman effect for anharmonic motion. Anharmonic motion. Number 3, anharmonic motion selection rules in selection rules here. For this, selection rules are selection rules. That is, delta nu is going to be plus or minus 1 or plus or minus 2 or plus or minus 3. So on hinga hogtade. ನಿಮಗೆ ಆಲ್ರೆಡಿ ಏನು ಗೊತ್ತದ್ರಿ, ಏನು ಎನರ್ಜಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದೀವಿ ನಿನ್ನೆ. ಎನರ್ಜಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದೀವಿ ರಿಯಲಿ. ವಾಟ್ ವಿ ಗಾಟ್ ದಟ್ ಆರ್ ವೇವ್ ನಂಬರ್ ಹೆಂಗ್ ಬರ್ತದ ಹಾರ್ಮೋನಿಕ್ ದು. ಅಂಡ್ ಹಾರ್ಮೋನಿಕ್ ವೇವ್ ನಂಬರ್ ಹೆಂಗ್ ಡಿಫೈನ್ ಮಾಡಿದೀವಿ. ದಟ್ ಇಸ್ nu bar of nu. Wave number nu bar of nu is equal to nu plus 1 by 2 times of omega e. Then ಅದರ ಜೊತೆಗೆ anharmonic constant term add ಆಗ್ತೈತಿ. That is going to be nu plus 1 by 2 times whole square into omega e xi. Xi is called as ಏನಂತ ಕರಿತೀವಿ ನಾವು, harmonicity constant ಅಂತ ಕರಿತೀವಿ, ಹೌದಿಲ್ಲ. Then ಇದರಲ್ಲಿನೂ ಕೂಡ ನಮಗೆ ವೈಬ್ರೇಷನ್ಸ್ ಬರ್ತಾವೆ ನೋಡ್ರಿ. ಇಲ್ಲಿ ಏನು ಎಕ್ಸೈಟೇಷನ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತಿತ್ತಲ್ಲ, ನಾವು ಈ ತರ ಬರಿಬಹುದು. ಇದು ಪ್ಯಾರಾಬೋಲಾ ಇರ್ತೈತಿ, ಇಲ್ಲಿ ಸ್ಟೇಟ್ಸ್ ಇರ್ತಾವ 1 2 3 ಅಂದ್ರೆ ಈಕ್ವಲ್ ವೇರಿಯೇಷನ್ಸ್ ಇರ್ತೈತಿ. This is nu bar nu naught, nu equal to nu equal to 0, nu equal to 1, nu equal to 2, nu equal to 3, so on ಹಿಂಗ ಹೋಗ್ತೈತಿ. ಕರೆಕ್ಟಾ? ಬಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಅನ್ಹಾರ್ಮೋನಿಕ್ ಒಳಗಡೆ ಅದನ್ನ ರಿಪ್ರೆಸೆಂಟ್ ಹೆಂಗ್ ಮಾಡ್ತೀವಿ. Anharmonic is not a perfectly parabola. It comes here, it is going to deviate like this. Anharmonic. And the spacing between the levels ಏನದ, levels means spacing between the levels unequal ಅದ, increase ಆಕೋತ ಹೋಗ್ತದೆ. Then last one state ಬಂದು there is going to be V max ಬರ್ತೈತಿ. Then that is called as dissociation vibrational quantum number ಅಂತ ಕರಿತೀವಿ ಆ ಪಾರ್ಟ್. ನೀವು ಇಲ್ಲಿ ಏನಾದರೂ ಸ್ಟೇಟ್ ವೈಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡತ್ತಿದ್ರಿ, you calculate the state wise here, this particular state. Then if you get the value of nu bar of naught means lowest level. That line, whatever the line is going to be there, that is called as excited line. Excited line ಅಂತ ಕರಿತೀವಿ, or relay line ಅಂತ ಕರಿತೀವಿ. Excited line wave number, or you can call relay line wave number. ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತೈತ್ರಿ. ಶಿಫ್ಟ್ ಇಲ್ಲಿ ಎಷ್ಟು ಕ್ರಿಯೇಟ್ ಆಗತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಡೆಲ್ಟಾ nu bar nu of a state, delta nu of Raman is equal to plus or minus omega e minus times 2 times of omega e xi. ನಿಮಗೆ ಆಲ್ರೆಡಿ ಹೇಳಿನಿ, ಫಂಡಮೆಂಟಲ್ ಫಸ್ಟ್ ಓವರ್ ಟೋನ್ ಬರ್ತಾವೆ ಇದ್ರಾಗ. ಫಂಡಮೆಂಟಲ್, ದಿಸ್ ಇಸ್ ದ fundamental one. This is fundamental one. Fundamental. What about the first overtone of the band? Vibrational Raman shift in first overtone band. Vibrational. Yesterday we have discussed about this, right? Vibrational Raman shift in first overtone. First overtone band. That is given by delta nu bar of nu Raman. That is equal to plus or minus 2 omega e minus 6 omega e xi. This is nothing but a first overtone. So hanga change ಮಾಡ್ಕೊತ ಹೋಗೋದು. Actually this is from nu equal to 0 to nu equal to 1, ಹೌದಿಲ್ರಿ. ಇದು nu equal to 0 to nu equal to 2. It's called first overtone. This is called as a fundamental. Next ಇದಕ್ಕೇನು ಕರಿತೀವಿ, nu equal to 0 to nu equal to 3 ಹೋತು ಅಂದ್ರೆ this is the for second overtone. Okay, this is what in case of vibrational. What happens in case of rotational Raman effect? So quickly ನೀವು ಹೇಳ್ಕೊತ ಹೋಗ್ಬೋದು ನೋಡ್ರಿ. That is given by rotational Raman effect. Rotational Raman effect. So ಇದನ್ನ ಹೆಂಗೆ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ? Same thing. When a pure rotational Raman effect arises due to the transition of a molecule from one rotation state to another rotation state. So firstly, pure rotational Raman effect. Pure rotational Raman effect. Pure rotation ಯಾವಾಗ ಸಾಧ್ಯ ಅದ? If the molecule is rigid molecule ಇತ್ತಂದ್ರೆ pure rotation ಸಾಧ್ಯ ಅದ. Pure rotational Raman effect. The selection rules ಏನೇನು? Delta J ಅಂತ ಗೊತ್ತು. J is nothing but a rotational quantum number. Here it is going to be 0 or plus or minus 2. Here its selection rule changes. Let's look at it. J equal to 0, relay line will be observed. When delta J equal to 0, then we call that one as relay line will be observed. Relay line will be observed. Okay. Observed. Delta J equal to 0 means no change in the rotation of the molecule. Its meaning is no change in rotation of the molecule. Rotation of molecule. No change in rotation of the molecule. When delta J equal to 2, ಆಯ್ತು ಅಂತಂದ್ರೆ then Stokes lines will be observed. Delta J equal to plus 2. Delta J equal to plus 2 ಇತ್ತು ಅಂದ್ರೆ then we call that one as Stokes lines. So this is nothing but in this part absorption of energy will be takes place. Stokes lines ಒಳಗಡೆ frequency ಕಡಿಮೆ ಆಗ್ತದೆ. Frequency ಕಡಿಮೆ ಆದ meaning ಏನು? So energy will be absorbed. Absorption of energy takes place. Molecule ದಿಂದ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿದೆ ಏನಾದ್ರು ಲೈಟ್ ಅದರಲ್ಲ ಅದ್ರಾಗಿನ ಫ್ರೀಕ್ವೆನ್ಸಿ ಚೇಂಜ್ ಆಗ್ತೈತೆ ಸ್ಕ್ಯಾಟರ್ಡ್ ಆದಾಗ. ಕಡಿಮೆ ಆಯ್ತು ಅಂತಂದ್ರೆ ಅಲ್ಲಿ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಆಗ್ಯದ ಅಂದಂಗೆ. Absorption of energy takes place. If the delta J equal to minus 2 ಇತ್ತು ಅಂದ್ರೆ then we call that as anti-Stokes line. So we call that part as anti-Stokes lines is going to be treated as here emission of energy. Right? Therefore, if you calculate the Raman shift here, rotational Raman shift. If you calculate the rotational Raman shift, rotational Raman shift is given by delta nu bar of A of Raman. That is given by, that is equal to plus or minus 4b times J plus P by 2 times of theta. J goes from here 0, 1, 2, 3 ಹೋಗ್ತದೆ. So this is what shift. So ಈಗ jth level energy ಏನಾಗಿ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ? For example, wave number of jth level of a Raman, that is given by B into J plus 1 ಬರಿತೀವಿ. Then what about change should be ಏನಾಗಿರ್ಬೇಕು? J value ಒಳಗಡೆ delta J should be equal to 0 ಆಗಿರ್ಬೇಕು ಇಲ್ಲ plus or minus 2 ಆಗಿರ್ಬೇಕು. Once check it, then what about the wave number of a J plus 2 state? That becomes B into, J value becomes now J plus 2 into J plus 3 into J plus 3. Now if you take the difference between these two, then that is delta nu bar equal to 4b times, that is J plus 3 by 2. It depends whether it is greater ಆಗಿತ್ತು ಅಂತಂದ್ರೆ ಆಡ್ ಆಗಿತ್ತು ಅಂದ್ರೆ Stokes line ಅಂತೀವಿ, ಮೈನಸ್ ಇತ್ತು ಅಂದ್ರೆ anti-Stokes sorry ಇದ್ರ anti-Stokes ಅಂತೀವಿ, ಮೈನಸ್ ಇದ್ರೆ Stokes ಅಂತ ಕರಿತೀವಿ. Therefore here this case plus or minus ಅಂತ ಬರೀತೀವಿ. Plus represents anti-Stokes, minus represents Stokes. Is that clear? Therefore ನಾವು ಏನಾದರೂ ಅದನ್ನ ಇಲ್ಲಿ ಲೈನ್ ವೈಸ್ ಗ್ರಾಫಿಕಲಿ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ, so this is the nu bar ಅಂತ ಹೇಳ್ತೇವೆ. Nu bar in centimeter cube, centimeter. Okay. Let us consider incident light ಯಾವುದು ಬಂದದ ಅದ ಹೊಳೆ ಬಂದಿತ್ತು ಅಂದ್ರೆ ಅದಕ್ಕೆ ನಾವು excited line ಅಂತೀವಿ. I'll call this one as exciting line or relay line. In case of shift ನೋಡಿದ್ರಿ J equal to 0 ತಗೋರಿ. What about J equal to 0? It becomes something ಬರ್ತದೆ. ವ್ಯಾಲ್ಯೂಗಳು ಶಿಫ್ಟ್ ಆಗುತ್ತೆ. ಡೆಲ್ಟಾ ನೀವು ಫಸ್ಟ್ ಲೈನ್ ಶಿಫ್ಟ್ ಮಾಡ್ಕೊಂಡ್ರಿ, it will be from here to here, ಎಷ್ಟು ಆಗ್ತದೆ 6 ಆಗ್ತೈತೆ ನೋಡ್ರಿ ಈಕ್ವಲ್ ಟು 0 ತೊಂದ್ರೆ ತಿಕ್ಕೋರಿ ಈಕ್ವಲ್ ಟು 0 ತೊಂದ್ರೆ ಅಂತಂದ್ರೆ ದಿಸ್ ಬಿಕಮ್ 6b 6b ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ 6b ಅಂತಂದ್ರೆ ಒಂದು ಪ್ಲಸ್ 6b ಅನ್ನ ಇಲ್ಲಿ ಹಾಕ್ತೀನಿ ಇನ್ನೊಂದು ಮೈನಸ್ 6b ಅನ್ನ ಇಲ್ಲಿ ಹಾಕ್ತೀನಿ ಹಿಯರ್ up to here I'll drop to here. Okay, so up to here there is delta 6b 6b here difference 6b here difference. So let me call this is the one line, this is another line equal to 0 to that equal to 1 ತೋರಿಗ equal to 1 ತೊಂದ್ರೆ it becomes 5 by 2 5 by 2 no 7 by 2. If I take this is 2 j equal to 2 ತೊಂದ್ರೆ next j equal to 1 ತೊಂದ್ರೆ sorry j equal to 1 ತೊಂದ್ರೆ first. But if I take see delta nu bar for j equal to 0, I got this one as 6b difference. Now what about delta nu bar for j equal to 1? I get 10b difference. Isn't it? 10b difference. Next, what about delta nu bar for j equal to 2? Then I am going to get 14b difference. 6b ಆಯ್ತು correct 6b ಆಯ್ತು j equal to next state ಹೋಗ್ರಿ next state ಅಂತಂದ್ರೆ ಯಾವುದು equal to 1 state equal to 1 ತಗೊಂಡಾಗ shift ಅಲ್ಲಿ ಕ್ರಿಯೇಟ್ ಆಯ್ತು ಇಂದ ಹಿಡ್ಕೊಂಡು nu naught this is nu naught nu bar naught this nu bar naught to up to here take this as a 10b either nu bar to is it becomes 10b. There is another line here and here. Next ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ತನಕ ತೋರಿ next state ಗೆ you are going to get 14b. Then what about here to here, here to up to here, this is 14b again. There is another line. Can you see the difference between these? What is the exact difference between Stokes excited line to this first anti-Stoke line? These are anti-Stokes. Anti-Stoke. These are Stokes. Okay. Once we get this, what is the difference between first exciting line or relay line to first stroke? The difference between these two? 6b. What about here? 6b. What about here? This is 4b. What about here? That is 4b. Correct? Then ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ತನಕ ಮತ್ತೆ next 4b ಅದ. Next ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ತನಕ 4b ಅದ. ನಿಮ್ಮ ಕ್ವೆಶ್ಚನ್ ಕೇಳಬಹುದು. Wave number difference between two successive anti-strokes is. Wave number between two successive anti-strokes ಅಂದ್ರೆ ಯಾವುದು? Successive anti-strokes ಅಂತಂದ್ರೆ ಇವು. So ಇದರ ನಡುವೆ ಮತ್ತು ಇದರ ನಡುವೆ ಇರೋ ಡಿಫರೆನ್ಸ್ successive means 1 1 1. You have to know difference ಎಷ್ಟು ಅದ 4b ಅದ. Wave number difference between Stoke and anti-Stoke is Stokes lines is ಏನಂತ that is also 4b. ಬರೀತೀವಿ ನೋಡಿ ಕ್ವೆಶ್ಚನ್ ಹಿಂಗೆ ಕೇಳ್ತಾನ ಏನು ಕೇಳ್ತಾನೆ ಅಂದ್ರೆ wave number difference between two successive anti-Stokes. Two successive anti-Stokes. What is that? The next question is wave number difference between two successive Stokes. What is that? Next wave number difference between first Stokes to first Stoke and first anti-Stoke. First anti-Stoke. Can you tell me the answers for all these? To observe it, tell me the answers. So wave number difference between two successive anti-Stokes is 4b. This one is 4b. What about wave number difference between Stokes? That is 4b. What is asking here? Wave number difference between first Stoke to first anti-Stoke. What is that? Now check it. First anti-Stoke ಎಲ್ಲೈತಿ ಇಲ್ಲಿ ಅದ. Next first Stoke ಎಲ್ಲೈತಿ ಇಲ್ಲಿ ಐತಿ. What is the difference between these two? 12b.
12b.
What is the wave number difference between exciting line to Stoke or anti-Stoke? Wave number difference between exciting line to exciting line or relay line ಅಂತೀವಿ relay line to first Stoke or first anti-Stoke. How much that is? 6b. Now is that clear? Relay line ಅಂತೀವಿ ಏನು ಸೆಂಟ್ರಲ್ ಲೈನ್ ಐತಿಲ್ಲ, ಲೈನ್ ಏನಂತ ಕರಿತೀವಿ ನಾವು, we call relay line. Relay line. Now can you tell me the intensity ratio of first stroke to first anti-stroke? So he's asking intensity ratio intensity ratio of first stroke and first anti-stroke, of first stroke and first anti-stroke, first anti-stroke, first stroke and first anti-stroke. So how much? ನೋಡಿ ಫಸ್ಟ್ ನಾವೇನು ಹೇಳಿದ್ವಿ, ಸ್ಟ್ರೋಕ್ಸ್ ಟು ಆಂಟಿ ಸ್ಟ್ರೋಕ್ ಏನು ಬರ್ತೀವಿ ನಲ್ಲಿ, ಆಂಟಿ ಸ್ಟ್ರೋಕ್ ಟು ಸ್ಟ್ರೋಕರ್, ಸ್ಟ್ರೋಕ್ಸ್ ಟು ಆಂಟಿ ಸ್ಟ್ರೋಕ್, ದಟ್ ಇಸ್ ಆಂಟಿ ಸ್ಟ್ರೋಕ್ ಟು intensity of strokes. How much we got that? It is e power of minus delta e divided by kbt ಅಂತ ಬಂದಿತ್ತು ನಮ್ದು. ಹೇಳಿ ಡಿಫೈನ್ ಮಾಡೋದ್ರಲ್ಲಿ, if I take the ratio like strokes to anti stroke ಅನ್ನೋದು ಇದನ್ನ ರಿವರ್ಸ್ ಮಾಡ್ಕೋದು what I get here, I of strokes divided by I of anti stroke is equal to e to the power of eb delta e divided by kbt. How do you calculate delta e? ನೋಡಿ ನಮ್ಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತದ, delta e is equal to hc or h delta nu, but ನ್ಯೂ ಬಾರ್ ಡಿಫರೆನ್ಸ್ ಗೊತ್ತದ ನಿಮಗೇನು ಡಿಫರೆನ್ಸ್ ಗೊತ್ತದ in terms of wave number difference ಅದ. ಹಾಗಿದ್ರೆ can you tell me the frequency difference between strokes and anti strokes? frequency difference ಅನ್ನ ಎಷ್ಟು ಹೇಳ್ತೀರಿ? the wave number difference. ಹಾಗಿದ್ರೆ frequency difference ಕೇಳಿದ್ರೆ ಹೆಂಗೆ ಹೇಳ್ತೀರಿ ನೋಡಿ, ಡೆಲ್ಟಾ ನ್ಯೂ ಬಾರ್ ಅಂತ ಕೊಟ್ಟು 4b ಆದ್ರೆ ಡೆಲ್ಟಾ ನ್ಯೂ, because delta nu bar equal to c into delta nu, remember ಅಂದ್ರೆ ತಾಯಿಗೆ ಏನು ಬರ್ತೈತಿ ಇಲ್ಲಿ, ಈ ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಬರ್ತೈತಿ, isn't it? See, for example, delta nu bar we got that one as 4b ಅಂತ ಬಂತು ಅಂತ ಅನ್ಕೋ. What about delta nu? Delta nu is equal to it's 4b divided by c. Frequency ಅನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀವಿ, ಡಿವೈಡ್ ಮಾಡ್ತೀವಿ. Sorry, it should be reverse la. It should be reverse. Nu bar is equal to ಏನಂತ ಬರೀತೀವಿ ನಾವು, frequency is equal to c into nu bar. ಇವಾಗ c by lambda ಇರ್ತೈತೆ, delta nu should be equal to c into delta nu bar, then delta nu multiply, sorry, delta nu is going to be 4b ಜೊತೆಗೆ ಒಂದು c ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಡಿಫರೆನ್ಸ್ ಇದೆ. ಹಾಗಿದ್ರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಡಿಫರೆನ್ಸ್ ಅಂದ್ರೆ ಎನರ್ಜಿ ಡಿಫರೆನ್ಸ್ ಎಷ್ಟು ಬರ್ತೈತೆ, ಫಸ್ಟ್ ಆಂಟಿ ಸ್ಟ್ರೋಕ್ ಟು ಫಸ್ಟ್ ಆಂಟಿ ಸ್ಟ್ರೋಕ್, how much that is 12b ಅದು. 12b ಅಂದ್ರೆ ಎನರ್ಜಿ ಡಿಫರೆನ್ಸ್ ಎಷ್ಟು ಬರ್ತೈತೆ ಅಲ್ಲಿ, delta E is equal to h into delta nu. Delta nu is going to be now 40 times of c. This is nothing but 12 b c. For example, back substitute ಮಾಡಿದ್ರೆ real energy, intensity of the strokes to intensity of the anti-stroke is equal to e to the power of delta E, energy difference is going to be 12 times of b into hc divided by kVt. Is what that clear? So ಈ ತರ ಇಂಟೆನ್ಸಿಟಿ ರೇಷಿಯೋ ಅನ್ನ ಕೇಳ್ತಾನೆ. Done? So what exactly Raman spectra. Evening class that I am going to discuss about nuclear magnetic resonance, NMR and ESR and electronic spectra. ಮೊದಲು electronic spectra ಡಿಸ್ಕಸ್ ಮಾಡ್ಕೊಂಡು EMR ಅದಕ್ಕೆ ಹೋಗೋಣ. electronic spectra ಏನು ಬರ್ತೈತಿ, then ಲೇಸರ್ ನಾಳೆ ಮಾರ್ನಿಂಗ್ ನಾಳೆ ಈವ್ನಿಂಗ್ ಕ್ಲಾಸ್ ಹೋಗಿ ಲೇಸರ್ ಮುಗಿದ್ಬಿಡ್ತೀವಿ. ಲೇಸರ್ ಸಿಂಪಲ್ ಅದ, ಬರೀ ಫಾರ್ಮುಲಾ ಆಟ ಕೊಡ್ತೀನಿ ರೀ, ಡೆರಿವೇಶನ್ ಅದಾವ ಅದನ್ನೇನು ಮಾಡ್ಕೊಂಡು ಕೊಡೋಣ. ಲೇಸರ್ ಫಿನಾಮಿನಾ ಸಿಂಪಲ್ ಐತಿ, ಭಾಳ ಏನು ಡಿಫಿಕಲ್ಟ್ ಇಲ್ಲ, ಜಸ್ಟ್ ಫಾರ್ಮುಲಾಗಳು ರಿವೈಸ್ ಮಾಡ್ಕೊತ ಹೋಗ್ಬೋದು ಲೇಸರ್ ಒಳಗಡೆ. ಓಕೆ, ಸೊ evening class that I am going to discuss about electronic spectra. Evening ಒಂದು 1.5 hour ತಗೋಣ ಕ್ಲಾಸ್, 1.5 hour ತಗೊಂಡಿ ಅಂದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕವರ್ ಅಪ್ ಆಗ್ತೈತಿ. Is that clear? Okay then. See you evening.